Alright guys, welcome to graphing cosecant and secant graphs. Okay, so what we're going to do is describe what these two graphs look like. We've already talked about sine, cosine, tangent, and cotangent. So we're going to get a description of each of these graphs, and I'm going to show you how to graph two of them. So we're going to start with secant x, which is the reciprocal of cosine of x. So the period, just like its cosine, is 2 pi. The domain is going to be all real numbers except multiples of pi. The range here is going to be from negative infinity to negative 1 in union with 1 to infinity. Okay? And our vertical asymptotes here are at odd multiples of pi over 2. And if you think about that, secant is equivalent to that 1 over cosine of x. So wherever the cosine value is 0, secant's going to be undefined, and that's what we mean here. So think about cosine of pi over 2 is 0, 1 over 0 is undefined. So let's look at the graph. Now in red here, I have the cosine graph, and that's going to be really important. We're going to use our cosine and sine graphs to help us. Okay, so here's my cosine graph, and notice at the zeros of cosine are my purple lines. The zeros of cosine are the asymptotes of secant of x. So at negative pi over 2, pi over 2, 3 pi over 2, and negative 3 pi over 2. Those are asymptotes of secant of x because that's where cosine is 0 and that's where secant would be undefined. So to draw these graphs, it's pretty simple. I just look at the maxes and the minimums of cosine, and I draw really parabolas, and I follow my asymptotes. When I have maximums, my graph's going to go up. When I have minimums, the graph is going to go down. Okay, so this is the general shape of a secant function. Now, in the second graph here, we have y equals cosecant of x. Now, remember, cosecant of x is the same as 1 over sine of x. So when we look at the characteristics here, we know that the period is 2 pi because the period of sine is 2 pi. The domain is all real numbers except integral multiples of pi. So that means integer multiples of pi. Okay? The range is going to be from negative infinity to negative 1 in union with 1 to infinity. And the vertical asymptotes are integral multiples of pi. Again, the asymptotes occur where sine of x is 0 because 1 over 0 is undefined. So when we look at the graph, again, my red graph is the sine of x, it's a parent function, okay? And from there, to draw cosecant of x, I look at the zeros. So I look at the zeros of my sine function, and notice how you see my purple vertical asymptotes at negative 2 pi, negative pi, 0, pi, and 2 pi. Integer multiples of pi are where the zeros are of cosecant of x. So I go ahead and draw my asymptotes in. Again, look, where my maximums are, my graph is going to look like a parabola going up following the asymptotes. Minimums, the graph's going to go down and follow the asymptotes. So let's look at just two quick examples of these functions. In my first example, it says use the graph of y equals 2 sine of 2x to obtain the graph of y equals 2 cosecant of 2x. Okay, so what you want to do is the graph of 2 sine of 2x is in red. So from here we can draw our cosecant graph of 2x here. So what I did is with the red graph, I first went and said, okay, where are my zeros? The zeros of my sine graph are going to be the asymptotes of my cosecant graph. So I go ahead and plug those in. Now this graph was already nicely done, so I already had my nice intervals. In the next example, I'll show you how to get these intervals. So I look at my zeros of sine. I draw my asymptotes. Okay? Then I look at my maxes and mins, and I start drawing my parabolas. Okay? And wherever the maximums are, I'm drawing them up. Notice how the maximum here is 2. So if you look at that max, there's 2, and I'm drawing my parabola going up. My minimums, okay, are negative 2, and so I'm going to draw parabolas going down following my asymptotes. And so the green graph there represents the graph of y equals 2 cosecant of 2x. So the underlying theme here is we can get our cosecant and secant graphs based on our sine and cosine graphs. Now, in the last example, here, I have graph y equals -3 secant of x over 2 for pi, negative pi to 5 pi. Now these are open intervals because this is where our function would be undefined. Okay, that's why there's open at the asymptotes. So in this example, I don't have the period, I wasn't given anything. So let's see how I would do that. Number one, I'm going to plot the same function, and I'm just, instead of secant x, I'm going to graph cosine, because those two functions are related. So I'll plot y equals -3 cosine of x over 2. That's the red graph you see here. Okay, so now the period is 2 pi over 1/2, which is 4 pi. My interval spacing is going to be pi divided by, or my period divided by 4, which this would give me pi. My amplitude is 3. So I'll sketch the graph. So each one of my tick marks is worth pi based on my interval. Okay, so I start at negative pi, go negative pi, 0, pi, 2 pi, 3 pi, 4 pi. Some of you are asking, do I have to label each tick mark? No, I only labeled a couple here. Just as long as your tick mark's in the right spot and you're using the right tick marks in the labels, you're fine. You don't have to label every tick mark there. So I labeled my tick marks, okay? And then my max was 3, my minimum was 3, but since A is negative, I start down at negative. So I go my 5 key points. So minimum, 0, maximum, 0, minimum, 0. And I go ahead and sketch that curve from negative pi to 5 pi. That's the cosine graph. Second, sketch the asymptotes. So where the zeros are of my cosine graph are the asymptotes of my secant graph. So at negative pi, okay, pi, 3 pi, and 5 pi are the asymptotes in this case because those are the zeros. I go ahead and mark them. Okay, and then I sketch that graph. I look at my minimums and my maximums and I make those parabolas following the asymptotes. So it's pretty straightforward. So that's graphing cosecant and secant. If you guys have any questions or comments, you can go ahead and type them below and we'll see you next time.